And I'm going to try to describe the motivation and the thinking behind the somewhat complex proof that we tried to prove in class today. And so I'm going to try to take it step by step. Okay, if you recall, this is the premise, and the premise is an existentially quantified disjunction. And the goal was to prove that that can prove that there's an existentially quantified P of X or existentially quantified Q of X. So we go from existentially quantified P of X or Q of X to existentially quantified P of X or existentially quantified Q of X. So to do that, my first observation is to note that my premise is an existentially quantified sentence. And the only way to break that up, so to speak, is to use existential elimination. So my overall strategy will be to use this form right here. And this form is existential elimination. So what I have is I have the first sentence, which is that existentially quantified disjunction. So my premise is this form where phi is P of X or Q of X. The thing that I need is universally quantified phi implies psi, where phi implies psi will be P of X, Q of X, implies my goal, which is existentially quantified P or existentially quantified Q. So that's what my goal is to create so that I can then use existential elimination to get, so that I can use existential elimination to get to psi. So stating that again, I already have phi. I need to generate or prove implication, and then I need to universally quantify that implication, and then I can use existential elimination to get psi. So let's see if I can do this. So my first goal is to introduce an assumption. And I think that my assumption should be something like this. So I'll put it in P of D or Q of D, where D is a placeholder with no restrictions, and D could be any one of the object constants in our universe. So that's an OR statement, and the only way to break it up, so to speak, is through OR elimination. So now I'm going to use OR elimination in this form right here. So let me see. That means I already have the OR statement. So that means now I need to prove two implications. So let me see if I can do that. Okay, so to prove two implications, that means I need to start with an assumption. And my first implication needs to be of this form, P of D, and then I'm going to try to prove then, okay, so I'm going to try to prove existentially quantified P of X or Q of X. So how do I do that? So if I know P of D, where D is a placeholder for any object constant, I can do existential implication, or introduction, I mean, where I'm replacing D with X. Because what does this say? It says if a specific P of D is true, then I can say that there exists some X such that P of X is true. That's existential introduction. That's relatively easy. But I don't need it. I don't need that. What I actually need is I need to actually introduce an OR, and I'm going to add to the EX, I'm going to add QX. So now, once I do that, whoops, I made a mistake. Um, Wrong format, easy to do. Add that in. And now I have E of x, P of x. I'm going to delete the one I don't need just to, just to get it out of here. And there we go. So now what I have is, in this implication, I've proven P of D implies E of x or E of x, EX PX or EX QX. So I'm going to click on those two and do implication introduction. All right, so I have this sentence right here now proven within the subproof. I'm going to do the exact same thing for Q of D. So introduce, instead of P of D, let's see, I'll introduce Q of D. I'll assume it. And using the exact same logic, I'll do an existential introduction where once again I'll replace D with X. Whoops, I forgot to choose which thing I was existentially introducing, and replace D with X, and I get EXQX, which I really need the OR statement. So luckily I can do OR introduction easily enough. And instead of adding QX to that, I'm going to add PX. I'm going to disjunct it with P of X. And so here it is, PX QX, and I'm going to delete the one I don't need. And now notice, let's see that I've assumed Q and gotten EX, PX, or EX, QX. So I can do implication introduction. There we go. And now this is the important part. My overall strategy within the subproof was to get the disjunction, and then the disjunction along with the two implications where that antecedent matches the disjunct. So P of D matches here and Q of D matches here. And most importantly, that the psi is the same, that the consequent of each of these implications is identical, namely EX, PX, or EX, QX, same here. So now that I have that, I have 1, 2, 3. That's these three sentences here that I can use OR elimination on. And that gives me EX, PX. And so you notice now I'm in the highest level of my subproof, where I assumed PD or QD, and it led me to conclude within the subproof EXPX or EXQX. All right, so now I can do implication introduction, yay, but that's not really the form that I want. If you remember what I actually want here, I want to do existential elimination. And so I have this existential and I have this sentence right here, but it won't let me do existential elimination because remember, I need it in this form. I need the existentially quantified sentence and then the universally quantified sentence. Actually, it says D here, but I need X's there. So my next step then is to take this and do universe. Remember, this PDQ or QD, D is a placeholder with no restrictions on it now because it's outside of the subproof. So I'm going to do universal introduction. I'm going to replace D with X. And once I do that, there I have the universal introduction. And now look at this. This is the key thing. Here and here. That's this sentence right here, the disjunction, which is existentially quantified, and the implication that is universally quantified. That's this right here. Existentially quantified sentence, and then universally quantified sentence where the antecedent, that's an implication where the antecedent is is the same as the existentially quantified sentence, and the consequent is our goal. So now I can use existential elimination, and that was the goal. And that's how you prove it. Um, there are several key things I recommend to you. Number one is I had to play around a little bit trying to get all of my variables right and my thinking right. But once I thought of doing this step, then the second phase of this nested subproof was simple because it's identical. And but I had to get my overall strategy in place first. And my overall strategy was to try to get something well, this is given, and so I needed to get something in this form. So I needed to recognize that pxqx was my phi, and expx or exqx is my goal, and that's how I did it. So your job, and what I recommend you do, is always keep this like notes to yourself on the side as you use the editor to try to go through this proof. All right.